Hi everyone, thank you very much for your time today. Really glad to have you here at the Spark Summit session. So my name is Antoine Amend. I'm the Technical Director for Financial Services at Databricks. Prior to joining Databricks, I was leading an AI practice for a retail bank in the UK. And really as a head of data science and leading data transformations, I went through the challenges of deploying machine learning models in production. And doing machine learning is difficult. Production machine learning in financial services in highly regulated environment is really complex. And how Databricks is positioned to help you move quickly through validation and audit, having a more transparent and reproducible view of your machine learning model lifecycle. So before we get started, a survey from the FCA, the Financial Conduct Authority in the UK, that says that FSIs only have, in average, 6 AI applications running live. There is a really low success rate of artificial intelligence, machine learning, or simple data science in financial services. And in fact, 85% of your data science-related project will never get into the world of production. And I may argue, being a data practitioner in that field, that the remaining 15% are not necessarily the most successful project neither. The reason is that you have to go through so many different gates, through many different processes, through so many different organization challenges when it comes to delivering models, that by the time your model gets delivered to production, it may no longer achieve the business outcome that you want it to. So when we look at those inefficiencies or those pain points when it comes to delivering machine learning in production in a bank, there is, in my view, it's not just IT related. It's mainly organization related. It's mainly being able to have the word of regulation, risk and compliance, accepting their model. There need to be a model validation. There need to be a customer privacy check. There need to be a human in the loop. There need to be someone accountable. And as I was leading that practice, obviously, I don't want to go to jail. I don't want to go to get my name in the news headline tomorrow because of AI in the bank. So there really is that level of compliance, of comfort of doing something for the right reason, having a control in artificial intelligence. Business versus AI, so many times we've seen the hype of AI versus the pragmatic approach to data science. So AI is not the end goal. AI or machine learning is a way to deliver business value. So sometimes data science is not even the right answer to the problem that you're solving. AI and regulation, there are strict rules on things that you cannot do, but there are lack of guidance in things that you can do. Can I use that feature for that specific purpose? There is a new work that is being regulated today in financial services around the use of AI and fairness. And as regulators and policymakers are stepping into the world of AI, it's really now key as data practitioners to have this more transparent approach to data science. When it comes to IT, someone working on production system, their job is not to deliver your machine learning model live. Their job is to keep the lights green, to make sure that the bank system will not fall apart a day before Christmas. They need to make sure that you have change windows. You need to make sure that your model fits with the SLAs, is covered as part of your IT service management. And there may be some inefficiencies along the line, such as a poor data management or legacy technologies, on-prem infrastructure. But 40 plus 20 is not 100. The remaining 40% are the accumulation of all those pain points that makes the cycle really long in a bank. And as I was saying, when it takes 12 months to deliver a model in production, in average, that would be the industry average in financial services, then the outcome is no longer the expected outcome. The data has changed. The customer has moved. There may be, in 1 year time, already a couple of reorganization in the company, some shifts in priorities. So reducing that time to market to maximize the business impact. This is how Databricks helps, not to help you necessarily into getting a better model or a smarter model, but bringing this more disciplined and transparent approach to AI, having Delta Lake to version control your data, to have a more reliable view of your data, and having MLflow to bring more reliable view of your insights. At the end of the day, if you don't have the data right, you will never get data science that you can trust and act upon. So bringing Delta and MLflow as a governance and a more transparent approach to AI will bring all the different contexts, the technical and business context, all the audit aspects, all the traceability, the lineage that you will need to comply with, and resulting in shortening that time to production from 12 months down to 3 months, down to a month. Knowing that a financial services company, you will never get a self-learning model without any human oversight. But being able to deliver a model faster within a month time is what industries are looking at today. So this series of a notebook that I want to cover today are really using a credit risk model as an example, but showing how we can start using, even if I want to stay into the world of pure Python, doing some simple data science, but benefit from the Databricks environment, the Databricks runtime, the integration with MLflow and Delta Lake to create a model that goes faster into production. So in this case, I want to use credit risk model to detect whether the propensity of a customer to default on a loan application. So I will be using Delta Lake and MLflow. But first, I said, let's get the data right. So the idea is leveraging Delta Lake to bring customer information, customer demographics, loan application data, and bureau data into one place I can trust and act upon, and enabling ML reproducibility. So in this case, I want to create few tables, such as my customer bronze, silver, and gold, my raw data, transform data, and enriched data that is ML ready. Delta Lake provides ACID transactions, schema enforcement, schema evolution, as well as file compaction. In this case, I have my table of customers. And in fact, I want to transform that table into a so-called SCD type 2, slowing changing dimension type 2. This is not an easy undertaking into the world of big data, into the world of file-based systems such as Hadoop, or even on cloud, just S3. Because you will need, for every new customer that you insert in that table, you will need to insert a new line, but you will need to also update the previous record. And from my experience, was one of the main pain points that we had from enabling machine learning in production in a bank, was having trust in customer demographics and being able to join customer demographics at the time of the transaction. So really enabling banks with answering a simple question, such as how many unique customers, how many active customers do you have across your different products and services, is not an easy if we don't get access to this level of information in the Delta Lake table. So this is my raw information, and I want to use to modify the schema to make that SCD type 2 compliant, so that we will have this information in one single source of one single place, one single source of truth. So I want to append my schema, create an additional column, create an effective start date and an effective end date. And showing you, although we could merge those two SQL code into one, for the sake of clarity, I want to show you how to simply insert new records and update previous records. So that if I change my address, I will get a new line in that database, but I will also get a merge, an update. So we'll be doing an upsert of finding the previous record that was valid for me, making that now invalid, and closing that date with effective start date and effective end date. So I can validate my data here and show that, yes, indeed, I've been able now to have two records for Mr. Congram Keeper. That's the synthetic data that I'm pulling here, valid from 1st of Jan 2008 to 1st of March 2020. That record is no longer active because that customer moved on the 1st of March 2020. I will be able then to join my application data as of those specific start date and end date. I'm doing the same for application data, applying some simple transformations, such as cleaning the, doing some simple cleaning here, doing some simple transformation, and doing my join at this specific point in time. My data set being on Delta Lake is now audit ready. So we can travel back in time. We can understand what my SCD type 2 table was 2 days ago, what my loan application data was 3 days ago. That provides this level of audit here available, and I can select my data as of a specific version to enable reproducibility of my ML experiments. So why we're getting into all of this when all we want to do is doing some simple data science is because we will need to comply with audit and regulation, risk and compliance about our use of data. And they may come back with us with some series of questions that we will need to reproduce. So if we're not able to reproduce our data, we'll never be able to reproduce our insights. So let's get now into the world of ML. So I have my table of customer demographics enriched with loan application data, and I want to predict my customer default on default payment. I want to stay in the world of pure Python. I don't want to stay into the world of PySpark. I don't even want to bring like distributed programming when my data is quite small. And yet I want to benefit from my Databricks runtime, Databricks environment, MLflow integration. So I can pull my information coming directly from Delta that comes with all my metadata that may be stored with more data types and your different features, retrieve my different table version, as I showed you, and retrieve a specific version as of a specific version or timestamp as of a specific version to enable that ML reproducibility, and then get into the world of pandas. So this is my data frame, with my target variable being whether or not I default or not. So doing some simple exploratory data analysis, simple as usual in the world of pure PySpark, pure pandas and Python. So doing some graphs using Matplotlib or Seaborn or any third-party libraries that you know, or the built-in visualization from Databricks. Handling categorical data, as I will be doing in usual. Handling correlation against my target variable. I will need to be able to bring that transparency to my auditors, to bring that explainability. Why did I decide to use that feature of this model or that model based on empirical evidence and not just random guess. So I will need to comply back with audit with why did I selected those features. So in this case, I have my positive correlation and negative correlation. So in the world of credit scoring, if I'm in the working class and I'm a man and I dropped off after secondary school and I'm still living with my parents, I may have a higher propensity to default rather than if I do have a good credit score and a higher education background. At this point, you may be jumping off your chair thinking that I may not be allowed to use the specific features, and you will be absolutely right. And this is what I will be covering in a few blocks, in a few cells here away. So let's get into just quickly the world of modeling. So I have my imbalanced data. I want to rebalance, to downsample my negative class or to upsample my positive class, split between train and test, standard data science here, and evaluate multiple models. So I want to use a logistic regression, a decision tree, a random forest, a gradient boosting. I want to use different hyperparameters and use cross-validation to find the best model, the best fit for my model. But I want to start capturing all of those experiments through the use of MLflow. I want MLflow to track all those experiments, to log those different models, parameters, as well as my Delta Lake version, so that we keep that version alongside our model binary. We want to evaluate based on the area under curve of the route curve. We want to select the best model based on empirical evidence. So those will be all the different experiments that we run. But because we run that using MLflow, our models are now available here within the MLflow tab. And you can access this MLflow experiment page that will show all the different experiments that you've led, that contains all the metadata that you've stored, that contains all the binaries that you've been able to log. So I can compare those different experiments. I can say what model has the best accuracy or the best score. So I will be able to get into this. Each model will be stored. I'm storing the model binary not just the pickle file, but the environment file. What version of what model of what library did I use for that purpose? So I can retrieve all those different experiments and run a simple validation across all the different experiments to understand what's my best model. And the reason I'm saying that is from a model compliance and delivery. One of the main questions you will ever get from model risk management is, why did you decide to go from a random forest and not a decision tree? Why did you decide to get through a logistic regression and not a gradient boosting? Because of those evidence that you will need to store, to capture, to track, and to deliver to your independent validation units. So from a model delivery and compliance, you will also need to articulate each and every single feature used in your model. Why did you decide that those features were important? So extracting the feature importance as a graph, storing that as a disk, on a disk, or as a CSV file containing all my metadata, my business metadata, my technical metadata, together with the correlation, the importance, the data type, the description. This programmatically then, as a CSV, will be able to attach that to my best model experiment. So my model, my best model, I want to store the ROC curve to show that we've led multiple experiments. We want to store all the experiment IDs. We want to store all the features. We want to show the feature importance. We want to store all those evidence and submit our model to ML registry. Doing that programmatically, you can see that now we've created a new model called credit risk as of version 1. So if I go to my ML registry and I search for credit risk, I see my model, I see my version 1 that contains all the context that I will need from an independent validation unit from a model risk management standpoint. And I can go, this version 1 that is now immutable is linked to that specific experiment ID that now contains my evidence from a model risk management standpoint, as we've logged onto MLflow. But what is also linked to the exact notebook at that specific revision ID. So suddenly, we created reproducibility in terms of data, reproducibility in terms of code, reproducibility in terms of insights, and this is what all matters from an audit standpoint. So I have my model, and as an independent validation unit, so I just need to retrieve my model, I will be evaluating that model. I want to transition that to staging area, or it could be whatever tag you want that to be. Could be validation. I want to transition that to validation. Someone will be looking at this, manually reviewing that, and realize that I'm using age and gender and features that I'm not allowed to use. I want to reject that, and that will be back to square one. So now, as a data scientist, I will need to validate those different questions. I just opened that notebook again. Model delivery and compliance. So I will have a lot of different questions that I will need to comply with from a model risk management standpoint. And hopefully most of those questions have been addressed already. What is the business purpose of which that model was built? Is your model reproducible? Yes, it is. What alternative approaches have you evaluated, and why did you decide that this approach was the best? Because we evaluated multiple models, see as evidence attached to this model. What feature did you use? We use that feature for that specific reason that contains that specific importance, and so on and so forth. Is your model discriminatory to a specific population? It appears that it is. So from a regulatory perspective, our model is illegal. But from an ethical perspective, it's also highly unethical. So in this case, I do have a clear, obvious bias in my model. And I could run a simple experiment. 12% of my rejected credit score, credit application would have been accepted if I were a female or a male. So which is clearly not the right thing. So my model is biased, illegal, and unethical. And getting into the world of AI and ethics quickly, it's not as easy as removing the gender from the modeling standpoint, because your model then may piggyback on an existing feature as a proxy for gender, for instance. If you look at the organization, if you work in kindergarten or if you work in security space, there may be slightly more different chances of you being a male or female applicant. And in fact, this is what you may have seen in the news over the past couple of years. of companies being flagged as being discriminatory because they remove gender from their modeling because it's illegal to use, yet to realize that our model was implicitly biased. So again, it's a really, really difficult topic here that we're only just uncovering, but that means that as a data practitioner, we'll need to get the right approach to machine learning. And last but not least, why not then getting a template notebook that contains all your model risk management, all your IT governance, all your data governance questions, so that as a data practitioner, you just need to put your code here where you have to answer those type of questions and effectively reduce the time it takes from ideation to production. Thank you very much for your time today, and I'm more than happy to answer any question that you may have, and let's reduce that time from ideation to production together. Thank you very much.